Beyond the window, the night sky is drifting very slowly. A few distant lights are still awake, while most of the world seems to have fallen silent, leaving only the steady rhythm of breathing and the gentle darkness surrounding everything. Perhaps this is one of the rare moments in the day when time no longer urges us to go anywhere at all. Just a quiet pause, a space to sit still, to listen, and to let the mind move a little more slowly beneath the vastness above. Tonight, we will step softly into a question that has followed humanity for centuries. How old is the universe, truly? The number 13.8 billion years has become familiar, almost like an unshakable truth. And yet, the deeper astronomers look into the darkness of space, the more they begin to feel that the story may not be entirely complete. So let the distant light of the stars guide this journey, a slow and gentle passage through time, through the memory of the universe, and through the things humanity is still learning how to understand. No one has ever seen the birth of the universe. No one truly stood there to witness the universe's first moment. No eyes saw the first light appear within the darkness. No memory was preserved from the moment everything began to expand in silence. And nowhere in space was there some enormous clock, quietly counting the billions of years passing by. Humanity arrived very late. We awoke on a small planet beneath a sky full of stars that had already existed long before the first living beings ever learned to look upward. And so, to understand the age of the universe, humanity had to learn how to listen to the traces left behind. Like someone entering a quiet forest and trying to guess which seasons have passed from the color of leaves resting on the ground. Perhaps you have seen the rings inside the trunk of a cut tree. Each thin circle of wood is a silent year that has gone by. The tree does not tell us its age with words. It simply keeps those soft and delicate layers of time within itself, like a patient memory. Ancient fossils are much the same. A fragment of bone deep beneath the earth, a faint mark within cold stone. All of them feel like whispers from a very distant past. Scientists do not see how those creatures once lived. They do not see the ancient oceans or the first atmosphere of Earth. They only look at what remains, then slowly gather the pieces into a story. The universe is understood in much the same way. No one witnessed its birth. But throughout space, time has left behind small traces, silent and enduring. Light from distant galaxies, the slow movements of the sky, and ancient radiation still drifting through the cold darkness of space. All of it feels like warm ashes remaining from a fire that burned long ago. And humanity, through its quiet curiosity, began learning how to read those traces. What is strange is that the deeper we look into the universe, the more everything seems to be moving away from everything else. Galaxies drift silently apart in the darkness, like boats slowly separating across an endless nighttime sea. If time could be reversed, if all those movements turned backward, there would come a moment when every distance drew closer together. Galaxies were once nearer. Stars had not yet formed. Matter had not yet separated. And long before every familiar shape existed, the entire universe may once have been in a state so hot, dense, and small that it is almost impossible to imagine. Humanity calls this idea the Big Bang. But the name sometimes makes people imagine a violent explosion inside a dark emptiness. In truth, it is closer to the unfolding of space itself than an explosion within it. Not a sphere bursting outward into empty space, but empty space itself beginning to expand. Intensely fast, intensely hot, then gradually cooling across billions of quiet years. And from that slow unfolding, everything emerged. The first stars, the first galaxies, clouds of dust drifting through darkness. Then planets, oceans, breath, consciousness. Small human beings sitting beneath the night sky, wondering where all of this began. And yet, this model is not a perfect memory of the past. It is the most beautiful and reasonable explanation humanity currently possesses, built from countless fragile traces still remaining throughout the universe. Like standing beside the sea at dawn and watching the waves, trying to imagine the wind that passed through during the night. Science, in its own quiet way, is often like that. It is not always made of certain answers. Sometimes it is simply the act of sitting for a very long time before the darkness, patiently observing very small things, then learning how to connect them together with humility. And perhaps that is what makes the story of the universe feel closer to us than we expect. Because within our own lives, human beings also live through traces. An old scent, a room filled with the fading light of late afternoon, a song once heard during distant years. We cannot return to the past, yet sometimes a small remaining light is enough. And memory opens slowly, like the night sky gradually appearing behind drifting clouds. Perhaps the universe is doing the same thing. It does not tell its story with words. It only leaves behind light. And for centuries, humanity has remained beneath that sky, quietly learning how to listen. When humanity discovered that the universe is expanding, and as humanity continued listening to that light for longer and longer, it slowly began to realize that the night sky was not still at all, despite its quiet appearance. For thousands of years, the stars seemed to remain where they had always been, hanging silently above oceans, deserts, and rooftops across countless generations. The sky felt so stable that people once believed the universe itself might be an unmoving stage, where every celestial body had been placed in a fixed position from the very beginning. But sometimes, the deepest truths do not arrive like thunder. They come very slowly, like a soft wind touching the surface of still water. Somewhere in the early 20th century, a Belgian priest named Georges Lemaitre spent long hours sitting with equations and with his own silence. He looked at the sky not only through the eyes of a scientist, but also with the patience of someone accustomed to reflecting on time and existence. And within that quietness, an idea slowly appeared. If the universe today is filled with enormous distances, if galaxies lie so incredibly far apart, then perhaps, long ago, everything was once much closer together. Space itself might not be motionless. It might be expanding. At the time, the idea sounded almost impossible to believe. Not because it was too strange, but because humanity had become so accustomed to the feeling that the universe was eternal and unchanging. A fixed sky felt far safer than a universe silently in motion. But the light continued telling its story. At the observatory atop Mount Wilson, Edwin Hubble spent many long nights observing distant galaxies through a giant telescope. Within that cold and quiet darkness, he began noticing something deeply unusual. Most galaxies seemed to be moving away from us, not in any direct visible sense, because the distances between them were far too vast for human eyes to perceive motion. But their light had changed in a very small, very delicate way, like the sound of a train slowly fading into the night. When a sound moves farther away, its tone becomes deeper. And light, in a certain sense, does something similar. As galaxies move away from us, the wavelength of their light stretches outward. Its color slowly shifts toward deeper reds, softer, warmer, more distant. Astronomers call this phenomenon redshift, the shifting of light toward red, a name that feels as gentle as the final colors of sunset. And it was this quiet shift that revealed something extraordinary. The space between galaxies is gradually expanding over time. It is not that galaxies are flying through emptiness like stones being thrown outward. Rather, the very fabric of space itself is slowly stretching, carrying every galaxy farther apart in silence, like tiny ink marks on the surface of a balloon that is steadily being inflated. Each mark sees the others drifting away, not because they are moving on their own, but because the surface beneath them is expanding. That idea changed the way humanity saw the entire universe. The night sky was no longer an unmoving dome. It became a river in motion, something with a history, a past, a capacity for change, and perhaps a beginning far beyond memory. Later, scientists realized that the farther away a galaxy is, the faster it appears to be moving away. A simple yet profound pattern, as though the entire universe were gently stretching itself in every direction. This gradually became known as Hubble's law. But on quiet nights like this, perhaps it feels like more than a scientific law. It feels like a small reminder that everything in the universe is moving, even the things we once believed to be unchanging. Galaxies drift farther apart. Light grows older along its journey. Space quietly becomes wider, little by little. And time continues flowing through everything like a slow river no one can truly see. And strangely, the deeper humanity explored, the smaller it began to feel beneath the sky. Not in a frightening way, but more like standing beside the ocean at night, listening to distant waves, and suddenly realizing that the world is far larger than the mind once imagined. Perhaps the astronomers of that era felt the same thing when they discovered that galaxies were not standing still, waiting to be observed. They were already traveling, and they had begun that journey long before Earth held its first oceans. Every beam of light that reaches our eyes is something moving through time. Every small point of light in the sky carries with it the story of millions, sometimes billions, of silent years. And perhaps that is why the night sky always feels so gentle. Because when we look upward, we are looking at something that has never stopped moving, yet moves too slowly to make any sound at all. An immense transformation unfolding in silence, like time passing through a human life. Like hair gradually turning silver beneath the warm light of evening lamps. Like the late night slowly settling over the world at this very moment. While far beyond us, the galaxies continue drifting apart through the bottomless dark. Quietly, endlessly, without rest. Light, humanity's time machine. And within that silent movement, light continues its journey without rest. It travels across the cold and immeasurable depth of the universe in a passage so long that the human mind can scarcely hold it completely. A beam of light leaves a distant star, then continues onward for millions of years, quietly drifting through darkness before finally touching the eyes of someone gazing upward on a very late night on Earth. What is strange is that light, no matter how fast it moves, still needs time to travel. Light from the moon reaches us in just over a single second. Light from the sun takes about 8 minutes, which means that every morning, when sunlight touches a window, we are seeing the sun as it was 8 minutes ago. Even the closest things in the sky already belong slightly to the past. And as distances grow larger, that past grows deeper as well. There are stars whose light takes hundreds of years to reach Earth. There are galaxies so distant that their light began its journey before humanity learned how to write. Before the first cities, before ancient civilizations rose and disappeared beneath the dust of time. The night sky, in its own gentle way, never shows us the present. It always shows us memory. Every point of light is something that happened long ago. Perhaps that is why, when people look upward into a quiet night sky, they often feel a soft sadness that is difficult to name. Not exactly loneliness, but something closer to standing before a river of time so vast that every light within it seems to be retelling something already gone. Andromeda Galaxy still appears silently in the darkest skies, like a faint and distant mist. The light we see from it tonight left Andromeda around 2 million years ago. When that light first began its journey, humanity did not yet exist in its present form. There were no cities, no language, no one sitting beneath lamplight at night, wondering about the universe. That light crossed nearly the entire history of humankind simply to arrive here. And tonight, it touches our eyes very softly. There are galaxies far more distant still. So distant that their light began traveling when the universe itself was young, before Earth existed, before the sun burned bright, before the first oceans. When astronomers point their telescopes toward the deepest dark regions of the sky, they are not only looking farther into space, they are looking farther back into time. The farther away something is, the older it becomes. The darker the sky grows, the closer we move toward the universe's beginning. And slowly, telescopes became something more than instruments of observation. They became quiet and patient time machines, not the kind found in loud science fiction stories. No roaring engines, no violent spirals of light, only enormous mirrors standing beneath the night sky, patiently gathering faint rays of light that have wandered through space for billions of years. Each time humanity builds a telescope larger and more sensitive than the last, we look a little farther into the past of everything. Like standing beside a lake late at night, trying to peer beneath still water in search of memories resting at the bottom. There is something deeply beautiful about that. Human beings are small creatures living on a small planet, and yet we are able to follow the history of the entire universe using nothing but light. Not by touching it, not by leaving this world, only by quietly observing rays of light that arrived late. And perhaps it is precisely that lateness that shapes the entire story of astronomy. Light always tells the story of where it once belonged. A star may have changed long ago. A galaxy may no longer resemble the form it had when it sent its light outward. There are even stars whose light still reaches Earth, though the stars themselves faded into darkness long ago. We see them, not as they are, but as they once were. That is what makes the universe so different from ordinary human life. In daily life, we are always trying to hold on to the present moment. But in the sky, the present scarcely exists. Everything is an echo of time. And perhaps that is what makes the night feel gentler. Because when we look at the stars, we are reminded that not everything must happen immediately. Not every answer needs to arrive within a single moment. Even light must be patient. It travels for immense lengths of time before reaching its destination. It quietly crosses darkness for millions of years without ever hurrying. And now, in this quiet night, between slow breathing and the soft light surrounding the room, perhaps we too can allow our minds to slow in the same way, drifting gently through the vast current of time, while beyond us, ancient rays of light continue silently searching for their path toward Earth from places humanity has never touched. Relativity and the time of the universe. And perhaps, once light had become the bridge between humanity and the past of the universe, another quiet question slowly began to emerge. If everything in space is moving, if light itself needs time to arrive, then what truly is time? For a very long time, humanity believed that time was like a straight and steady river, flowing the same way everywhere, an invisible rhythm shared equally across the universe. But then Albert Einstein began looking at the world in a different way, gentler, stranger, and far more expansive. He imagined that space and time were not separate things at all. They were woven together like soft threads within an invisible fabric covering the entire universe. Every star, every planet, every galaxy rests upon that fabric. And the fabric itself is not perfectly flat. It can bend, it can stretch, it can tremble softly beneath the weight of matter and energy. Like the surface of a still lake changing shape after a single drop of water falls into it. Perhaps the strangest part was this. Gravity was no longer seen as an invisible force pulling objects toward one another. Instead, space-time itself changes shape around massive objects. The sun does not pull the Earth in the way people once imagined. It bends the space-time surrounding it, and the Earth simply moves quietly along those curves in a journey lasting billions of years. Everything in the universe seems to move across a soft fabric that is always changing, very slowly. And that means time itself is not entirely fixed. In places where gravity is stronger, time moves a little more slowly. Near immense objects such as neutron stars or black holes, that slowing becomes so profound it is almost impossible to imagine. But even here on Earth, it is quietly happening all the time. Time passes slightly differently atop a mountain than it does at sea level. Very small, very difficult to notice, but real. And once humanity began to understand this, measuring the age of the universe became something very different. Because if space itself can expand, and if time can change speed under the influence of gravity, then the age of the universe is no longer as simple as counting years the way we count the age of a tree or a stone. It becomes the story of space-time itself, a story in which distance, light, motion, and time are all bound together, like currents of water merging into one within the darkness of the cosmos. When scientists observe galaxies drifting apart, they are not merely measuring movement. They are trying to understand how the fabric of the universe has changed across billions of years, how quickly it expanded, when it slowed, and what invisible forces may have quietly shaped that entire journey. For a time, humanity believed that the gravity of all matter in the universe would eventually slow expansion down, like a ball thrown upward into the sky, gradually losing momentum before falling back. But then the universe revealed another surprise. Its expansion does not appear to be slowing, it seems to be accelerating, very gently, very slowly. Yet enough to make astronomers feel that somewhere out there, something invisible is silently influencing the structure of space itself. They call it dark energy, a name that sounds more like darkness than a true explanation. Because even today, no one fully knows what it is. We only know that it seems to exist everywhere, quietly pushing galaxies farther apart as time passes. Much like dark matter, another invisible presence humanity cannot directly see, but can only sense through its gravitational effects on galaxies. In some way, The universe appears to be made mostly of things humanity does not yet truly understand. Light reveals only a very small part. Most of everything else still hides within deep darkness. And perhaps that is what makes the night sky feel so quiet. Because the longer humanity observes it, the more it realizes that the universe is not a simple machine that can be dismantled and fully understood through a few equations. It feels more like an ocean deeper than imagination itself, where every answer opens into even larger regions of darkness beyond. Even time is no longer a straight road. It can stretch, it can slow down, it can become inseparably bound to the shape of space itself. And that makes the question of the universe's age feel far softer than before. Not simply, how many years have passed, but rather, how has space-time changed in order to create this present moment? Perhaps somewhere among distant galaxies, time itself is flowing at an entirely different rhythm from the quiet room where we are sitting tonight. And yet, all of it still belongs to the same vast fabric. A fabric that has been silently trembling for billions of years, eventually giving rise to stars, oceans, late-night skies. And this very moment, when a small human being quietly wonders about the age of the universe beneath the gentle light of evening. And beyond us, space-time continues to expand, without sound, without hurry. So slowly that it almost resembles absolute stillness. The cosmic microwave background, the oldest light. And within that slow expansion of space-time, among galaxies silently drifting apart through endless darkness, there remains something ancient that has never completely disappeared. A light older than any star humanity has ever seen. Older than the first galaxies themselves. So old that it began its journey when the universe had no planets, no skies, no familiar forms of any kind. And that light is still here, very faint, very cold, passing through us constantly, unnoticed by human eyes. In the earliest moments of the universe, everything was so hot that light could not travel freely. Space was like a dense ocean of energy and restless particles moving in chaos. Light continuously collided with matter, trapped and scattered within a blazing fog, with no open path through which it could escape. The universe at that time was not dark. And yet, it could not truly be seen through, like trying to look through muddy water in the middle of a storm. Then time passed. Space continued expanding. The temperature slowly fell. And eventually, in a moment unimaginably far in the past, everything became cool enough for light to travel freely at last. The universe became transparent. Not transparent like glass or a still lake, but transparent in the sense that light could finally move great distances without being trapped inside that primordial sea of energy. That moment was like an immense veil of mist slowly dissolving after an endless night. And light was released into space. It began its journey in that ancient era, and it has never stopped traveling since. Across billions of years, as the universe expanded wider and colder, that ancient light cooled as well. Its wavelength stretched outward, becoming softer, weaker, gentler, until it remained only as a faint microwave radiation quietly filling all of space. A soft echo from the childhood of the universe. Humanity calls it the cosmic microwave background. But the name sounds almost too technical for something so strange and so quiet. Because in truth, it feels more like the lingering light of the universe's first dawn. What is remarkable is that humanity did not discover it through some dramatic search. Like many great discoveries in science, it appeared almost by accident. In the 1960s, two researchers named Arno Penzias and Robert Wilson were working with a giant antenna designed to receive radio signals. But no matter how carefully they adjusted it, a faint noise always remained, arriving from every direction in the sky. It would not disappear. It did not depend on day or night. It did not come from cities, from equipment, or from Earth itself. They checked everything they could imagine. They even cleaned bird nests and layers of dust from inside the enormous antenna, hoping the strange noise would finally vanish. But it remained there, quiet, steady, like a distant whisper that had never stopped echoing since the beginning of time. And eventually, humanity realized that they had encountered the oldest light ever observed. A remaining trace from when the universe itself was only a few 100,000 years old. There is something deeply beautiful in that thought, that after billions of years of expansion, after countless stars were born and faded away, after galaxies drifted apart through darkness, the universe still preserved a small memory of its youth, like warmth lingering within a stone long after sunset has passed. And the more carefully humanity observed this ancient light, the more it realized that it was not perfectly uniform. There were tiny fluctuations within it, delicate ripples, almost like faint waves moving across a lake at night. Those fragile variations eventually became galaxies, star clusters, immense regions of space, and finally, everything we know today. Satellites such as COBE, WMAP, and Planck were sent into space to listen more carefully to that ancient echo. Not through sound, but through delicate maps of temperature and light spread across the sky. Like people sitting very still in darkness, trying to hear a song that first began billions of years ago. And from those almost imperceptible traces, humanity began measuring the age of the universe with unprecedented precision, around 13.8 billion years. A number born not from some giant clock suspended in space, but from ancient light still quietly passing through us every day. And perhaps that makes the night sky gentler than ever before. Because somewhere around us, even within this quiet room tonight, waves of light still exist that began traveling when the universe itself was very young. They pass through walls, through our bodies, through the night air without making a single sound. Ancient memories are still moving silently, and humanity, with its small yet persistent curiosity, continues sitting beneath the sky and listening, as though the universe itself has never truly stopped telling its story, only that it has always spoken in a very quiet voice. The Lambda C, the dim model, the universe's current map. And the longer humanity listened to that ancient echo, the more it tried to gather those scattered fragments of light into a gentle map of the universe. Not a map of roads or familiar oceans, but a map of existence itself. A way of understanding what fills the endless distances between galaxies, what holds stars together, and what has been quietly guiding the slow expansion of space-time across billions of years. What is strange is that when humanity began calculating everything it could see, stars, planets, gas clouds, galaxies, light itself, it realized that this entire familiar world makes up only a very small part of the universe. Everything ever touched, seen, or named resembles little more than bright grains of dust floating upon a vast nighttime sea. Everything else remains hidden in darkness. A woman named Vera Rubin spent many years quietly observing the motion of spiral galaxies. She watched stars near the outer edges of galaxies orbiting their centers, like small leaves drifting around an immense current. According to what humanity understood at the time, Stars farther from the center should have moved more slowly. But they did not. They continued moving incredibly fast. So fast that those galaxies should have flown apart long ago if only the visible matter existed within them. And yet they remained there, stable, quietly turning within darkness for billions of years. And that led people to sense that perhaps something invisible surrounds galaxies. A form of matter that emits no light, reflects no light, and cannot be directly seen, yet still exerts gravity, like the night wind, invisible to the eye, yet felt through the movement of leaves. Humanity called it dark matter, a simple name for something almost no one truly understands. And then, when scientists looked even farther into the universe's history, another mystery emerged from a silence deeper than darkness itself. Space is not only expanding, its expansion is accelerating. Galaxies are not merely drifting apart. They are moving away from one another faster and faster, as though something unseen were quietly stretching the very fabric of space-time forever outward. An invisible force unlike anything humanity had ever known before. No one has seen it directly. No one truly knows what it is. People only know that it seems to exist everywhere, woven into the structure of the universe itself, profoundly quiet, yet unimaginably powerful. And so the name dark energy appeared, a name that sounds more like emptiness than explanation. But sometimes science is simply the act of standing beneath the night sky and giving names to things still beyond reach. And when all those fragments were placed beside one another, the universe's ancient light, the motion of galaxies, the expansion of space-time, humanity gradually formed a model describing the largest picture it had ever known. A model now called, in a quiet and easily forgotten way, Lambda CDM. Yet behind those symbols lies an immense story about everything that exists. Within that story, stars, planets, oceans, and even humanity itself occupy only a very small fraction of reality. Most of the universe is made of invisible things we know only through the effects they leave behind. That may sound distant, but in some quiet way, it also feels strangely gentle, because it reminds us that the universe is not a place already fully explained. It still contains unnamed darkness, much like the human mind itself, always carrying regions of memory and feeling we do not completely understand. And despite all its mysteries, the model works remarkably well. It helps humanity trace the formation of galaxies, understand how light travels through time, measure the age of the universe, and predict the immense structures drifting through deep space, like a map drawn from light and mathematics, accurate enough to guide us, even while many regions near the edges remain unfinished. Perhaps that is the most beautiful thing about science. Not the feeling of knowing everything, but the ability to continue walking through the unknown without ever ceasing to observe. Humanity has never seen dark matter directly. It does not yet understand what dark energy truly is. It still does not know why space-time expands in this way. And yet we continue sitting beneath the night sky, quietly measuring light, listening to faint signals drifting through emptiness, and trying to understand the story being told across billions of silent years. Some nights, when thinking about these things, the universe no longer feels like a cold machine. It feels more like a bottomless ocean, breathing very slowly in the dark. And every galaxy is merely a small point of light drifting upon that endless water. Even now, while the room grows quieter and the night beyond the window continues moving softly onward, galaxies are still turning within halos of invisible matter, Space-time is still silently expanding, and light from the beginning of the universe is still passing gently through us like a memory that has never completely faded. A vast story still unfolding, very slowly, very far away, and very quietly. Hubble Tension, a quiet conflict in cosmology. And although that ancient light allowed humanity to arrive at what seemed like a remarkably stable number for the age of the universe, the quietness of the sky has not truly closed every question. Because the more carefully scientists measure, the more deeply they listen to the signals arriving from space, the more they begin to notice something very small, yet significant enough to soften the entire story, to make it feel slightly uncertain, like the surface of night water touched by a faint ripple. The universe does not seem to tell exactly the same story through every method of measurement. When humanity studies the ancient light remaining from the beginning of time, the data points toward a certain rate at which the universe expands, a slow and steady unfolding inferred from the memory of the early cosmos. But when scientists observe nearer galaxies, regions of space that are younger and closer to the present, the results become slightly different. Not dramatically different, just enough to create a discrepancy that refuses to disappear. Like two clocks measuring the same long night, yet always remaining a few minutes apart, no matter how carefully they are adjusted. And that changes the quietness of the night sky in another way. It is no longer only a place filled with distant mysteries, but also a place where the numbers themselves begin whispering that humanity may still be missing something. To measure distances in the nearby universe, astronomers study special stars known as Cepheids. These stars brighten and fade in steady rhythms, almost like slow breathing in the middle of the night. And through those rhythms of changing light, humanity learned how to estimate their distances. Farther away still are certain stellar explosions known as Type 1a supernova. In their final moments, they shine with nearly the same brightness throughout the universe. And because of that, they become distant lighthouses, helping humanity measure the depth of space itself. Layer by layer, light forms small bridges across the darkness, from stars near Earth to distant galaxies, and finally to the expansion of the universe itself. And from those measurements came a strange realization. The universe today appears to be expanding slightly faster than the ancient light once suggested. The difference is tiny compared with the vastness of the cosmos. But in science, even a very small inconsistency can resemble a faint sound inside a perfectly silent room. Once it has been heard, it becomes difficult to pretend it is not there. Scientists call this the Hubble Tension, a tension between different measurements of the universe. It does not sound like the name of a great mystery. It feels more like a small wrinkle in the endless fabric of space-time. And yet, the more telescopes observe, the more data is gathered, the more that discrepancy remains. Quietly, persistently, without fading away. And perhaps the most beautiful part is that, instead of panic, humanity simply continues sitting down and listening more carefully. Because science, after all, is not a journey toward absolute perfection. It is more like walking slowly through fog, where each small light allows us to see only a little farther ahead. Perhaps the nearby measurements still contain delicate errors humanity has not yet recognized. Perhaps the ancient light from the early universe still carries meanings not yet fully understood. Or perhaps our current model of the universe is still missing some hidden piece deep within the darkness. A form of energy not yet known, a new property of space-time, or something for which the human mind still has no language. Some nights, when thinking about this, the universe no longer resembles a problem waiting to be solved. It feels more like a very long piece of music, one in which humanity has heard only the opening passages echoing faintly through time. And sometimes, it is the slightly imperfect notes that make the music feel deeper. What is remarkable is that despite this discrepancy, most of the story of the universe still works beautifully. Galaxies continue forming almost exactly as predicted. Light still moves according to familiar laws. Ancient signals still align with most of what humanity observes. Only somewhere within that immense picture, there remains a small region of darkness not entirely fitting with the rest, like a distant star trembling softly in the night. And rather than disturbing the peace of the sky, that uncertainty somehow makes the universe feel more alive, because it reminds us that human understanding is not a completed wall, but a small lantern continually carried deeper into the dark. Even now, while the night slowly continues beyond the window, telescopes on Earth and in space remain patiently gathering light from unimaginably distant places. Cepheid stars continue pulsing in their own rhythms. Ancient stellar explosions continue sending light across millions of years. And somewhere among all those quiet signals, the universe still seems to be telling us that its story may be far larger than anything humanity has learned so far. The cosmic distance ladder. And perhaps to understand why even the smallest difference in measurement can leave humanity so unsettled, we must return to something that seems far simpler: distance. In everyday life, distance feels easy to understand. We know how long a road is, how wide a room may be, or how far away a hill stands simply through sight and a few familiar steps. But in the universe, everything is so vast that ordinary ways of measuring almost completely dissolve. No one can stretch a rope from Earth to the stars. There are no markers suspended in space to measure each million light years. Humanity had to learn how to measure distance through light, through tiny movements, and through patience extending across generations, like someone walking through thick fog, finding the way forward only through the faintest possible signs. And so, measuring cosmic distances slowly became something like a long ladder built within the darkness. Each rung depends upon the one before it. Every farther measurement must trust a nearer measurement already made. Humanity calls this the cosmic distance ladder. But on a quiet night like this, it feels less like a scientific term and more like a chain of small lanterns hanging one after another across an endless abyss. At the nearest distances, humanity began with something surprisingly simple. When we look at an object from two different positions, it appears to shift slightly against the background behind it, like holding up a finger before your face and changing perspective between your two eyes. Nearby stars do something similar. As Earth moves around the Sun, the nearest stars appear to shift ever so slightly against the more distant stars beyond them. That delicate motion is called parallax, a movement so small that only extraordinarily precise instruments can detect it. And yet, from that nearly invisible shift, humanity first began measuring distances to nearby stars, like discovering the first rung of a ladder in the middle of the night. Later, spacecraft such as Gaia were sent into space to measure those motions with greater precision than ever before. Gaia quietly circles through space, observing billions of stars with almost endless patience, like a silent record-keeper of the sky. From those nearby measurements, humanity gradually learned the true brightness of certain special kinds of stars. And then, Cepheid stars appeared once more, like rhythmic lanterns within the darkness. They brighten and dim in steady cycles, like the slow breathing of the universe itself. And by understanding those rhythms, astronomers can determine how luminous they truly are. If we know how bright a lamp truly is, but see it only faintly from afar, we can estimate how distant it must be. Humanity began doing the same thing with galaxies. And farther still, Type 1a supernovae became bright markers across deep space. They erupt with nearly identical brilliance, bright enough to be seen across immense cosmic distances. Layer after layer, light continues building upward, from nearby stars to distant galaxies, and finally to the expansion of the universe itself. And at every level of that ladder, even the smallest error can spread farther upward through the entire structure. Like a compass needle drifting slightly away from true north, after a long journey, the traveler may end up hundreds of miles from the intended path. A tiny change in the measured distance to Cepheid stars can alter the estimated distances of supernovae, and that in turn changes the way humanity calculates the expansion rate of the universe. And ultimately, it changes the estimated age of everything. There is something deeply fragile and beautiful in that. Not the cold precision people often imagine science to be, but something more like a structure built from countless faint lights connected across billions of years of space, a chain of trust extending from one measurement to the next. And perhaps that is why astronomers spend so much time checking even the smallest details. A slight fluctuation in light, a tiny difference in the movement of a star, a distance changing only a little from expectation. Because at the scale of the universe, very small things can sometimes alter the entire story. There is something profoundly human in that as well. Sometimes, a single small memory changes the way we understand an entire life. Sometimes, one brief encounter quietly leads someone toward a completely different path. And the universe is much the same. Immense galaxies, billions of years, bottomless regions of space. And yet the understanding of all of it may depend upon tiny vibrations of light that humanity must sit patiently through the night to notice. Even now, while the world grows quieter and the darkness beyond the window continues spreading slowly outward, telescopes remain pointed toward the sky, patiently building that ladder of light, step by step, from Earth to the edge of time itself. A fragile ladder, yet enough for small beings on this planet to reach toward the age of the universe, through nothing more than their eyes and their quiet curiosity. And beyond us, the stars continue shimmering within endless space, as though they have never stopped leaving behind small traces for humanity to follow through the deep darkness of time. The oldest stars, witnesses of time. And so, among those ladders of light stretching through darkness, humanity began turning toward the oldest things the sky still preserves. Not the most distant galaxies, not the oldest signals, but the stars that have been burning through nearly the entire history of the universe. There is something deeply quiet about old stars. They do not explode violently like supernovae blazing in their final moments. They simply continue existing across billions of years, silently consuming their fuel within the deep darkness, like small lamps that have never gone out since the earliest days of time. At the edges of galaxies lie ancient star clusters known as globular clusters. From afar, They resemble soft spheres of light suspended within black space. Hundreds of thousands of stars gather together into dense and peaceful clouds of brightness, slowly orbiting galaxies like old memories that never truly left. Many of those stars were born when the universe itself was still young. Before the sun existed, before Earth cooled, before the first oceans. They were already there, long before any human story began. And even now, they are still burning. What is remarkable is that stars have lifetimes of their own. They are born from cold clouds of gas drifting through space. They grow, shine, and slowly change across millions and billions of years, eventually reaching different forms of old age. Every star is like a clock burning through light. If humanity understands how a star lives and ages, it can estimate how long that star has existed. Astronomers study the colors of stars, their brightness, the ways they change over time. Like someone quietly watching a candle flame and trying to guess how long it has already burned through the night. And when they examine the oldest star clusters, the numbers they find often come remarkably close to the age of the universe itself. That is what makes ancient stars such extraordinary witnesses of time. Like elderly figures still sitting quietly beside a window long after an entire city has changed through generations. They do not tell stories with words. They simply continue existing. There is one star that once drew particular attention because of this. An extremely old star, relatively near Earth, by cosmic standards, nicknamed the Methuselah star, after a figure said to have lived an extraordinarily long life in ancient human stories. When the earliest measurements appeared, this star seemed to be older than the age of the universe itself. A very strange thought. How could a star be older than the universe in which it exists? But as with many things in astronomy, the story did not become loud or dramatic. It became a quiet pause, inviting humanity to sit down and observe more carefully. The measurements were refined, the data was examined more patiently, and gradually, the estimated age of the star became more consistent with the current model of the universe. It did not completely overturn anything, but it was enough to remind humanity that measuring time in the universe has never been simple, because every measurement passes through light, distance, motion, and the delicate limits of human understanding. Perhaps the most beautiful part is that ancient stars do not stand there to argue against the story of the universe. They simply test it quietly. Like old stones beside a river, silently revealing how long the water has flowed past them. Each time humanity measures the age of an ancient star, it is also testing the larger story of time, expansion, and the history of the universe itself. And up to now, despite small inconsistencies, most things continue telling the same vast story. A universe approximately 13.8 billion years old. A place that has been expanding through darkness for an immense span of time. A place where light, matter, and time itself have all grown together across billions of quiet years. But that quietness has never meant that every mystery is resolved. Because the more humanity studies ancient stars, the more clearly it senses that it stands very near the edge of what is known. Beyond that edge, there is still darkness. There are still regions not fully understood, and perhaps that is not as frightening as it may seem. There is something gentle in knowing that the universe still keeps some of its secrets. That even after humanity learned how to measure light from the dawn of time, understand the expansion of space-time, and build ladders of distance stretching across billions of years, the night sky remains larger than every map. The old stars continue burning within that profound silence. very slowly, very faithfully, as though time itself is only a long river endlessly flowing past them. And even now, while the night deepens outside, the light from those ancient stars is still quietly traveling through space toward this place. Perhaps their journey began before humanity's first language existed, before cities, before every memory we now call history. And tonight, after a voyage almost beyond imagination, they touch the sky above us very softly, like the last witnesses still able to remember what the youth of the universe once looked like. James Webb and the shock from the early universe. And then, just as humanity began to feel familiar with the slow breathing of the universe, a new eye quietly opened within the darkness. Far beyond Earth, beyond the disturbances of the atmosphere and the lights of the human world, a telescope began looking deeper into space than any eye before it had ever managed to see. The James Webb Space Telescope does not observe the sky in the familiar way human eyes do. It sees through infrared light, softer and longer wavelengths capable of passing through clouds of dust and reaching far deeper into time, toward places where light itself began its journey almost at the dawn of the universe. Humanity sent James Webb into space, hoping to glimpse the universe's first young galaxies, faint points of light only beginning to emerge after the primordial darkness, like recovering the earliest photographs of the cosmos. But what appeared instead brought a different kind of quiet astonishment. Those ancient galaxies seemed to mature far too early. They were not fragile clouds of chaotic gas, as many had imagined. Some already possessed clear structures, large bright regions, dust, and signs that generations of stars had already formed and disappeared. In a few places, there even appeared to be enormous black holes already in existence. And all of this emerged during an era when, according to current models, the universe should still have been extremely young. Only a few 100 million years after the Big Bang. If the entire 13.8 billion year history of the universe were compressed into a single day, this would be little more than the first moments after midnight. And yet galaxies had somehow already grown faster than expected. There is something deeply strange about that feeling. Like opening a book and discovering that the characters in its first pages already carry the memories of an entire lifetime ahead of them. But instead of collapsing the story, it only makes the universe feel deeper. Perhaps the first stars formed more quickly than humanity once believed. Perhaps matter in the early universe gathered together more efficiently. Perhaps black holes grew at extraordinary speeds within the primordial darkness. Or perhaps there is still something about the universe's earliest years that humanity does not yet fully understand. James Webb does not declare that the universe is certainly older than 13.8 billion years. It does not destroy the old story. It simply places a gentle hand upon humanity's shoulder and whispers that the beginning of the universe may not have been as simple as we once imagined. Perhaps everything unfolded faster, much faster. What is remarkable is that the farther humanity looks back into time, the more the universe begins to resemble something alive rather than a cold machine. The first galaxies did not emerge slowly and empty. They seem to have begun building structure almost immediately after the primordial darkness started to fade. Like seeds sprouting rapidly after the first rain of time. Some of the images from James Webb feel almost like looking into the memory of existence itself. Soft red points of light suspended in immense darkness, arriving from an age when the universe seemed far too young to contain things so mature. And all of that light traveled across billions of years simply to reach human eyes during this very late era of cosmic history. There is something profoundly quiet about that. That ancient galaxies may have lived nearly their entire lives before Earth itself existed, and yet their light continued traveling through space, patiently crossing darkness until it finally touched small beings sitting beneath the night sky, wondering about the age of everything. James Webb does not offer absolute certainty. It offers depth, like standing beside the ocean at night and realizing the water stretches farther than the eyes can see. And perhaps that has always been the true nature of astronomy. Not a journey toward a perfect ending, but the process of learning how to live alongside the vastness of the unknown. The more powerful telescopes become, the clearer the images grow, and the more gently the questions continue expanding as well. The universe has never become smaller beneath humanity's gaze. It has only become deeper. Even now, while the night continues drifting quietly beyond the window, James Webb Space Telescope remains far out in space, turning its enormous mirror toward the oldest dark regions of the universe. It is still gathering rays of light that began their journeys near the beginning of time itself. Light older than every mountain on Earth, older than every memory humanity possesses. And somewhere within those soft red lights, the universe still seems to hold a few final secrets about its own youth. Not as mysteries demanding urgent answers, but as a very long story still being told within the peaceful darkness of space, little by little, very slowly, very softly. Conclusion: the universe is not only older, but more complex. And perhaps, after all the light that has traveled for billions of years to arrive here, after galaxies silently drifting apart through expanding space-time, after the ancient signals still lingering from the universe's first moments, the deepest thing that remains is not a number. It is the feeling that the universe is far larger than humanity ever imagined. Throughout this long journey, humanity learned how to read light the way one reads ancient words left upon the stone walls of time. We measured the motion of galaxies, listened to echoes from the primordial universe, traced the ages of the oldest stars, and slowly assembled a vast picture of the history of everything. A universe approximately 13.8 billion years old. Even today, it remains the strongest and most consistent model humanity has ever created. It explains so many things. Why galaxies move away from one another. Why ancient light still exists. Why the elements were formed. Why the sky appears the way it does today. Like a map drawn through the patience of generations of people sitting beneath the night sky and wondering where they are within it. But a map, no matter how beautiful, is never the entire ocean. And perhaps the gentlest thing science teaches us is not certainty, but humility. Because the more humanity understands about the universe, the more it realizes how much still remains unclear. Perhaps the first galaxies grew faster than expected. Perhaps the expansion of space-time is influenced by things not yet fully understood. Perhaps dark matter and dark energy are only temporary names for deeper mysteries still hidden within darkness. And perhaps somewhere beyond the edge of current understanding, there are still laws of reality humanity has not yet had enough time to discover. But that does not mean science is wrong. It only means the story is not finished yet. like standing beneath a sky full of stars and realizing that no small lantern can illuminate the entire ocean. Perhaps human knowledge has always grown in that way, not through immediately finding the final answer, but through slowly stepping deeper into darkness with patience and gentleness. Each generation sees a little farther, listens a little more carefully, understands a little more of the slow music the universe has been playing for billions of years. And sometimes, it is precisely the things not yet fully understood that make the journey more beautiful. Because if every mystery had already been completely explained, perhaps the night sky would no longer feel so deep. Perhaps humanity would no longer sit beneath the stars and feel its heart grow smaller before the vastness of time. And yet, we still do. From the first human beings gazing upward beside ancient fires, to the giant telescopes quietly turning through space today, humanity has never stopped listening to the universe. And the universe has never stopped telling its story. Perhaps somewhere within that endless darkness, time has already flowed through things the human mind cannot yet imagine. Perhaps galaxies will continue being born and fading away long after every city on Earth has turned to dust. Perhaps the light passing through this quiet room tonight began its journey before humanity itself existed. All of us. Every memory, every civilization, every brief human life. Maybe little more than tiny sparks appearing for a very thin moment within cosmic time. And yet there is something deeply warm in that smallness. Because even as small beings living on a small planet, humanity can still look upward and wonder about the age of everything. We can still listen to light, still learn how to read the ancient traces of space and time. Like small candles lit inside an immense cathedral of time. The light is small, and yet still enough to reveal a part of the darkness. And perhaps that is the most beautiful thing the universe has ever given humanity. Not every answer, but the ability to continue searching. Even now, while the night deepens beyond the window, galaxies continue drifting farther apart in absolute silence. Light from ancient stars is still traveling across the cold darkness of space. And somewhere unimaginably far away, the universe is still quietly continuing its own story through movements so slow they almost resemble stillness itself. And we, perhaps, have only heard the very first soft lines of that story so far.